All right, good morning, everyone. It is Tuesday. Ignore the time on my clock. I'm recording this on Tuesday night, and it is actually Wednesday that you are going to be watching this. We're going to be doing our lesson today, just like we did yesterday as a video, right? So today we do not have bell work. We're going to do a key ideas video, then notes, and then a practice. So there's no bell work, but you should have your binder and pencil in front of you. If you do not, pause this and go get those, right? And we are going to get started first with a video, right? In the instructions, it's going to go through and give you the instructions that you need when you need to pass out papers, what you're going to need, and we just need to make sure we're getting our work done today, right? So here we go, on to the video.
Energy is the ability to do work, but today it feels like energy is helping us to play. An amusement park is a classic place to understand kinetic and gravitational potential energy. Kinetic energy is the energy a moving object has because of its motion. Take a look at all of this kinetic energy. If it's moving, it's kinetic. Let's look at a car on this ride. Both mass and speed contribute to the kinetic energy of an object. So what does that mean? When the speeds are the same, the object with the larger mass has greater kinetic energy. When the masses are the same, the object moving faster has the greater kinetic energy. And of course, we need to look at gravitational potential energy. Potential energy is the energy stored in an object, like this ball. And gravitational potential energy is the energy an object has due to its mass and position above Earth. The higher I raise this ball, the higher gravitational potential energy, or GPE, it has. Now let's talk some GPE on some of these rides. Okay, where are we going to find the greatest GPE on this Ferris wheel? Since the ride is empty, this one is easy. Which one is up higher? Yes! The gondola on the top of the Ferris wheel has more GPE than the ones below it. As it goes up, it gains GPE. As it goes down, its GPE decreases. More mass increases GPE. So a full gondola has more GPE than an empty gondola at the same height. Makes sense. Now, onto a faster thrill. Where does the coaster have the greatest GPE? The top of a roller coaster's highest hill, of course. Now it gets exciting. A car poised at the top begins down the hill. Gravitational potential energy converts to kinetic energy, driving the roller coaster along the track for the whole ride. And the higher the hill, the more GPE. And back to how mass affects GPE. A car full of people at the top of a coaster hill have more than an empty car. So now you'll be able to take a look at these rides and make a hypothesis about which will have the greatest GPE and the most kinetic energy, which will have the least. Remember to consider height and mass to help you decide. Perhaps the even more compelling question is, how much kinetic energy is just right for you?
All right, you should have this paper in front of you. This is our potential and kinetic energy notes. We are starting on this side. This is the front, not the side with the roller coaster. We will get to that in a bit, right? So make sure you have your pencil ready. We are ready to go, right? At any point, if you need to pause the video for people to catch up, go ahead and pause it, right? And let's get started. I'm going to zoom into the top corner. We're going to start with potential energy, right? PE, right? So let's get started. Potential energy is energy that is stored. It's stored up, kind of like in a battery, right? Just like chemical energy has to do with batteries. We've talked about this before. Potential energy has the potential to do work. Remember, that just means it can do work. There are three main types of potential energy. Hopefully you already have them memorized. That is gravitational, elastic, and chemical. Right, first let's start with gravitational potential energy, or GPE. Gravitational potential energy describes the energy stored in objects that are above the Earth's surface. Right? The higher an object is off the surface, the more gravitational potential energy it has. Right? The higher something is, the more it has. Right? So here's an example, right? A kid on a slide. That would be an example of gravitational potential energy. As they're at the very top, right before they go down, they're high up off the ground, right? So they have high GPE, right? Sliding down to elastic, right? EPE, elastic potential energy describes the energy stored in objects that are stretched, I'm going to underline that, or compressed, right? It can be either way. It can be a rubber band, like you're pulling it, or it could be a spring, like in your pen when you push it. Either way, elastic, it's the same thing, right? When the object is released, the elastic potential energy turns into kinetic energy. It changes, right? Just like when you stretch a rubber band and then you release it, then it's going to turn into kinetic energy as it moves. So an example could be a bow and arrow before it is shot. Right, you pull that bow and arrow back so that that string is tight and it has EPE. Right, the last one for potential energy is chemical. And chemical potential energy describes the energy stored in the atoms that make up objects. The chemicals that make up food and fuel have stored up chemical potential energy, right? Food, fuel, batteries, and chemical reactions. These all have chemical potential energy. So an example could be gas in a car, right? It's sitting in the gas tank. It has that CPE, chemical potential energy. It has the potential to make the car be able to run. Right? Now we're going to slide over to the kinetic energy slide. Right? Kinetic energy, KE. Right? We should know a lot about this. Kinetic energy is the energy of motion. Kinetic energy depends on an object's mass and velocity, which is a fancy way for saying speed. I wrote that in the corner. The more massive and the faster the object is moving, the more kinetic energy. So here's some examples, like a car driving down a road, an airplane flying, an animal, moving. Those are all examples of things that are moving. They have kinetic energy, right? This is what the front should look like. You can pause it there if we need to get caught up. We are about to go on to the back. Right, now on to the back. Right, now we're talking about how potential and kinetic energy can change. They can change from one to another. Right, so we're talking about energy transformations. Right, energy can never be created or destroyed. This is super important. This is what we call the law of conservation of energy. I want you to write that on there. Right? That is something that we're going to be talking about a lot in this unit. Energy can never be created or destroyed. It just changes. So instead, it is transformed from one type of energy to another. Right? So when potential energy increases in a system, the kinetic energy must decrease. They're opposites. In math, you call this inverses, right? Kind of like 2, and the inverse of that would be -2, right? They're opposites, okay? So as one goes up, the other has to go down, right? So the opposite is true. When potential energy decreases in a system, the kinetic energy must increase. At any point in a system, the total energy will always be the same. So if you were to add up all the potential and all the kinetic all together, it's always going to equal the same number, no matter where it is on this roller coaster. Right, so here's some examples. A car stopped, begins to move, and a basketball player jumps. All right, they're standing there and they jump up to shoot the basket. That would be moving up. All right, now we're going to roll it onto the roller coaster down here. All right, so we have several different spots. We're going to talk about 2, 1, 2, and 6 are the 3 we're looking at. All right, so we're talking about 1. Remember, I've talked about we are going to see roller coasters a lot, right? So get used to seeing them, right? And learn it now so it's easier to remember, right? So at 1, it is the highest off the ground, right? Look at this compared to this point, right? That would be the other highest, right? And then this point, right? Well, this one's obviously way taller than the rest of them. So that is going to be the most GPE. So we're going to say most GPE. Right? It is the highest because it's the highest off the ground. Right? Remember, we also talked about how the roller coaster goes up, 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 and then it pauses before it goes down the hill, right? It stops for 2 seconds, right? So that would be the least kinetic energy, or KE, because it stopped moving for a second. Right, now let's talk about 2, right? As you go down the hill, these 2, they flip, right? Remember I said they're opposites, so they have to flip. So instead of the most GPE, this is going to be the least. And that's because it's the shortest point on the roller coaster. You can see that one is the shortest, right? 5 would also be really, really short, right? But we're only talking about 2 right here. So that one's going to be the least GP it could have, right? It's closest to the ground. This is also going to be the most KE because it's moving the fastest. As it goes down the hill, it goes faster and faster and faster and faster. And at this point, right, it starts to go back up, which slows it down. So this is going to be the fastest point on the roller coaster. Right, now let's go all the way down to 6. Right, I want you to notice that 6 is kind of in the middle right here. Right, it's like it's between these two, and 6 and like right here in the middle are about the same height. Right, so what's happening is as the GPE is going down, because the roller coaster is getting closer to the ground, right, the KE is also going up as it goes faster, so they kind of meet in the middle, right? If GPE was 10 and KE is 0, right, then right here in the middle, it would change to about like 5 and 5. And then at the bottom, say the least would be 0 GPE and the most would be 10 KE, right? That's how it would work if it was numbers, right? So right here in the middle, they're going to be about even. So we're going to put on 6 GPE and KE about even. They're about the same. Right? Go ahead and pause that right here if we need to finish getting the back done. Right? This notes is going to go into your binder. Right? And on to the next thing. All right, the next thing you need to have in front of you is a potential and kinetic energy reading with a couple of questions at the bottom, right? This needs to be passed out right now, so pause this and pass out this paper. Right, so what we're going to do on this paper is we're going to read through this. I'm actually going to read it to you, so you just have to follow along with me. Then we're going to answer the questions at the bottom, right? So following along with me, eyes on your paper, make sure you're paying attention. Here we go, at the top. Potential energy. Potential energy is energy of position or energy that is stored in an object. If you stretch a rubber band, you will give it potential energy. As the rubber band is stretched, potential energy is changed to motion. A pizza has stored chemical potential energy. As you eat the pizza, it undergoes a chemical change during digestion and is converted into energy your body uses to move and work all day long. The formula to calculate potential energy is PE equals weight times height. Kinetic energy. Kinetic energy is energy of motion. A rubber band flying through the air has kinetic energy. When you're walking or running, your body is exhibiting kinetic energy. The formula to calculate kinetic energy is Ke equals mass times velocity squared divided by 2. Energy transformations. Energy transformations take place when energy changes from potential to kinetic or kinetic to potential energy. Potential energy is converted into kinetic energy. Before a toy yo-yo begins its fall, it has stored energy due to its position. At the top, it has its maximum potential energy. As it starts to fall, the potential energy begins to be changed into kinetic energy because the yo-yo begins to move. At the bottom, its potential energy has been converted into kinetic energy so that it now has its maximum kinetic energy. A waterfall, like Bridal Veil Falls in Niagara Falls, has both potential and kinetic energy. When the water begins to fall, its potential energy is transformed or converted into kinetic energy. This change in energy at Niagara Falls is used to provide electricity from the transformation of mechanical and electromagnetic energy to parts of northeastern United States. All right, at the bottom, we're going to do this short thing real fast. You are going to have 3 minutes to answer these questions. It should not take you very long, right? If you need a little bit more time, that you can have up to 5 minutes, but really we should be done after 5. Right, so pause the video, you're going to answer the questions, and in 3 to 5 minutes, we're going to be back to go over the questions. So pause now. All right, we are back, and let's go over the questions, right? Your definitions do not have to be the exact same of mine because it says in your own words, right? It just has to be at least close, right? So what I said was potential energy is stored energy, right? Really simple. It's not super difficult. Just stored, right? It's stored up. Kinetic energy is energy of motion, right? So potential stored up, kinetic is moving. Right? Here's what you should have put for the other ones, right? Potential energy is C, which says the energy of position or energy that is stored, right? Stored up, it's stored. That was C, right? Then kinetic is D, which is the energy of motion. Converted is F, which says one thing that's changed into a different thing, right? It's converted, it changes. Maximum would be E, which is the opposite of minimum. Stored is A, contained or kept together in one place. And motion is B, and objects change in position over time. Those were the correct answers for the front. You can pause and fix them if you need to. Make sure your answers are correct on this paper. All right, now that this paper is done, right, the front is finished. If there's any time left in class, right, I want you guys to be working on the word search on the back, right? If there is not time to do this, that is okay, right? At the end of class, this paper needs to be turned in, right? At least the front needs to be completely done. That is not that much. Double check that your name and class period are on this paper, and one person from your table needs to go turn it into the box, right? So at the end of class, make sure this gets turned in.